Not that I know of, so it's time for
Okay.
you to call it to order.
All right, so let's get started. We'll call the meeting to order. This is three-member appeal panel hearing building board case number BCA-01-2013. And this is an appeal regarding the connection of roof diaphragms to shear walls, the blocking connection, and it applies to one- and two-family dwellings and townhouses. It is an appeal by Colony Builders for a residence that they've applied for a building permit for. The way that we'll conduct the meeting is that first all testimony will be given under oath, so I'll ask you to swear in before giving testimony. The staff will give a short outline of the case, and then the appellant will give their presentation. And then after that, staff will give their presentation. After that, either party can ask questions. And the appellant will also have a right of rebuttal after the staff's presentation.
And if I could help, after each presentation, there can be time for questions. So after the appellant has their, after the appellant makes their presentation, then questions through the chair from anyone, from the staff or, or any members of the board can be asked. And after the staff gives their presentation, questions can be entertained through the chair. So you don't have to have both presentations first, you can ask questions at the end of each.
Okay, so we'll have questions after each step. And then the three-member panel will begin discussions, and I think at that time we can continue to ask questions of the parties if they come up. So with that, I think we're going to start off with staff giving a brief summary of the case under consideration.
Excuse me, we need to do roll call first
Okay.
to put it into the record.
Okay.
Okay. Mr. Hawkinson?
Here.
Mr. Sterling?
Present.
Mr. Straight, sorry. And Mr. Feller?
Present.
Mr. Pinello?
Present.
Ms. Walsh?
Present.
Mr. Knopfinger?
Present.
Mr. Weaver?
Present.
Do I need to do a roll call as well?
I do it.
Dr. Wynn, present.
Bill Taylor, present.
Okay, thank you.
And on the phone?
And Jay Crandall, present on the phone.
Yes, thank you.
Jay, are you hearing everyone?
Case, sometimes only hearing about every other word.
Okay. Could we maybe move him closer to for the staff presentation just so he hears?
Oh, sure.
I just want to make sure he's, I can move him.
Let's, can we pull this table out in the middle?
Do that.
Yeah, we'll have it out. Yeah. Look back for Ross and Jared.
So let's go ahead and start with staff giving presentation of the outline of the case.
Okay, so for this appeal, as the chair had mentioned, that this appeal is an alternate means to the application of MOA handout RD 13, option 5. Mr. Taylor is requesting that the board reverse the decision made by the building official as far as the disapproval of the alternate means, and to allow for an increase in capacity. The contention is that the capacities developed for option 5 were not consistent with the IRC and are too restrictive with regards to the application and the development from testing.
Okay. So any questions at this point? All right, the next step will be for the appellant to present their case.
You need to swear them in.
Who's going to be presenting?
I'll do a brief introduction to our case, and then Jay will offer our primary testimony, and Bill will offer testimony as needed in response to questions. So I'm just going to summarize kind of our points. I don't know.
Okay, I'll just swear you both in, so
Okay.
you both hold up your right hand.
For all three.
Jay.
All three, okay. Do you affirm, under penalty of perjury, that the testimony you are about to give in the matter before us is the truth?
I do.
Yes, I do.
Yes.
Okay, go ahead.
Thank you, Mr. Chair. For the record, my name is Rebecca Wint, here representing Colony Builders tonight. I'm accompanied, as noted, by Bill Taylor, who's here to answer any questions regarding the specific property at issue, and by Jay Crandall over the phone, who will address the engineering aspects of our appeal. Jay is our engineering consultant. His resume was circulated last night by Tana. If any of you are missing a copy of his resume, I do have extras with me, as well as extras of the other reports he circulated last night. We're lucky to have Jay here with us. He has over 24 years of relevant research, engineering, and construction experience, and he'll actually answer the majority of the questions and make the majority of the presentation, because this is really his ballpark, not mine. I just wanted to make 2 quick points before passing it off to Jay. The first was to reemphasize the fact that, as noted, the central document at issue here is handout RD13. It's not an actual provision of the code itself. It's a staff interpretation of the code, and our request is for this panel to exercise its independent authority to provide a reasonable interpretation of the code and reconsider the nature of this element of the handout RD13. In relation to the specific property, also I wanted to note that this is, again, as noted, a request for alternate design materials and methods of construction, and our understanding is that the building code provides a different standard for review of this kind of request than for the review of a modification request. The relevant provisions and modifications are covered by 2310, 10310, and the alternative materials design and methods request is covered by 2310, 103, 311. So we've tailored our presentation to the standard for alternate design materials and methods of construction, but we are prepared to answer questions regarding the modification standard. If you want to treat this appeal under that standard, just let us know. We can respond to those questions. So again, to summarize, again, this appeal has sort of twofold for us. One is a request for a specific review of this request for alternate design materials and methods, and the second is to sort of a request for an independent review of this criteria contained in number 5 of handout RD13. So thank you again for your time, and I'll defer to Jay to carry on with our presentation.
Thank you, Becky. I guess I'm kind of glad to be here tonight at 10 o'clock to address this issue. Really, I guess to preface my statement, what's going on here is not about reducing the code or not meeting the intent of the code for safety or anything. It's really about alternative means and methods, which is the approach both codes, the IRC and the IBC, contain identical statements and provisions for situations just like this. And what I'll do in my testimony, I guess, is start off with the staff memorandum that was put out and kind of go through that, because I think that will sort of address the intent of the code. It will address the test data that's available and some other evidence that I'll share along the way. The first issue that was brought forward is, the IRC has a wind speed limit that at the wind speed at the site of this particular appeal, which is 125 miles per hour, as I understand it, kicks you into several other options than the prescriptive provisions in the code. And the prescriptive provisions would include various roof blocking details, which are in question. So it kicks you out from those to either several reference standards that the staff memo addresses and there's certain prescriptive clauses there, or it kicks you into the IVC for engineering. But the point is both of those documents and all the reference standards all are one way of doing things that are in the code. The alternative means and methods is meant to address the situation that we're dealing with here in the RD13 document. Whether you're operating in the IRC or IVC doesn't matter. So that's my first point, that a lot of the discussion around whether the IRC or the IVC applies and there's a different standard being imposed there is not the case. So both codes have alternative means and methods, and that's really what we're coming at this from. The second point in their memorandum is on page 3. Well, actually, it's the first point that they list is the relevance of ICC ES AC 13. And that standard is meant for testing for joists. It's a joist hanger type of test. It's not really relevant to this type of assembly test where we're dealing with lateral force transfer. That's dealing with gravity load transfer, the reliability indices or probability of failure that the code deals with that particular type of load action. Gravity load is different and always has been different than lateral loads. So I really don't see how that is relevant. Even the safety factor is not relevant. The right place to look is addressed in their point number 2. They're claiming that my prior information that I provided showing the safety factors in lateral force systems such as shear walls is not relevant, but it's exactly relevant. These blocking that we're dealing with is part of the lateral force system. The loads from the roof diaphragm go to the wall, shear walls or brace walls if you're in the IRC. And it's all part of the same system and assembly for transferring forces through the building lateral forces. So shear walls are tested as assemblies. And the roof blocking tests that were run and the 2 reports that were given were tested as assemblies. Generally, tests are done by approved agencies. In this case, the NAHB Research Center is an approved agency. One report was done for the United States Department of Housing and Urban Development. The other report was done in collaboration with the U.S. Department of Agriculture's Forest Products Lab. Both facilities have a huge amount of experience in wood frame construction. I myself have spent a majority of my career trying to bring a better understanding to engineering methods for homes, particularly looking at how assemblies really perform. Unfortunately, with shear walls, the design values that are used in the engineering code are based on index tests that have boundary conditions that are not even representative of the type of interaction between the shear walls and the remainder of the structure. And but the test that we ran remove all of those boundary conditions so that the assembly we're testing, this blocking and the force transfer between the roof and the wall system, is free to fail in any way that is the primary failure mode. It's a much more representative test than even the shear wall tests that are currently in the code. In my prior documentation, through several different approved agencies, not just the NAHB Research Center, but other agencies that have done a good bit of testing and constantly do code approval testing for various lateral force resisting systems, are showing that the values that are in the code provide a minimum safety factor of 2. And that has been a point that's been in contention. I don't understand why, because the data from multiple sources is indicating that. In fact, SBCRI Lab for the Structural Building Components Association has spent recently, in the past 2 years, $1.2 million looking at lateral force system behavior. their conclusions are the same. The ICC ad hoc committee that was put together to straighten out the wall bracing provisions in the IRC, which I was a part of, came to the same conclusion, and that safety factor is used there to upgrade recently all of the IRC wall bracing provisions, again with the safety factor 2. There's been peer-reviewed journal articles published that document that. So the reason that was done, myself and Zena Martin, who at the time was working for APA, American Plywood Association, the reason we did that was so that to avoid disputes or appeals like we're having right now. Unfortunately, for some reason, that's not being weighted, I guess, by staff. The staff in page 4 makes a claim that the second paragraph, the tests and results used by APA are the standard by which all wood frame construction is based on. That's basically making a claim that APA is the sole source for all design information and relevant to this matter. And there are a multitude of approved agencies. APA is a private sector organization and has a laboratory that's an approved agency, just like the NHB Research Center, just like the SPCRI lab, and countless others. To say that all has to comply with their data alone, I don't see how that follows. That's a sole source of a particular private sector institution, and excluding all the other data, that just doesn't make sense to me. The fourth point I'd like to make is they claimed in the memorandum in the next paragraph down, page 4, the fourth paragraph, that the data is not representative. This data covers a variety of conditions, from no blocking, which is an extreme lower bound, up to the condition of blocking. In many cases, the blocking that was tested would be weaker than having solid blocking between the trusses, which already 13 addresses. So the testing is not only representative, it covers a range of conditions from extremes that gives us more information than if only one condition had been tested multiple times. So this is the same way that the continuous sheet bracing method was put into the code. It was a series of single tests, but over a range of conditions to plot a trend, which is much more powerful in terms of its explanatory power than just spending a lot of time testing one thing over and over again. And so my response to this representative issue is that the testing we have is more than representative. And for example, as you look at one of the reports, I'll just mention one. They tested without blocking, and the one test with a 9 1/4 inch heel height. This is a 9 1/4 inch eccentricity with no blocking. Got 255 pounds per linear foot of force out of it. Okay, that as an ultimate load with a safety factor of 2, that would give you a value of 127 pounds per linear foot with no blocking whatsoever and a 9 1/4 inch eccentricity in the load path. What this appeal is asking for is about the same number, 125, no stronger than, no more force, no more strength being asked for design force than what the no blocking condition produced. And so I can't see how this isn't relevant and representative to the issue at hand. By assigning this blocking condition, the option 5 in that report, a 70 PLF value, is to say it's less strong than a condition with no blocking. It's basically making this more efficient and code compliant. It meets the intent of the code blocking procedure, not useful, purely because of the choice of a safety factor that is too high in comparison to other lateral force resisting systems in the code. The other point I'd like to raise is sort of jumping over to experience. I have been involved in a number of post-disaster studies, unique studies for HUD, for NHB, for other agencies, National Institute of Standards. The approach approach that we've used has been far more scientific than you'll find in other post-disaster evaluations. We set a benchmark there for using scientific method in the field studies, where we randomly sample homes from property tax records in the damage zone before we even went there, so that there would be no personal human bias in the selection of the sample, so that we would get actual data that shows the frequency of different types of damages and be able to actually discern cause and effect relationships and make good decisions about what should and should not be done in terms of building code to correct issues. And all of that data in the Hurricane Andrew, Hurricane Charlie, the Northridge earthquake, an S3 tornado, Hurricane Opal. I haven't counted the number of samples from those events, but probably more than 1,000 homes. There was not one case that I could find in those extreme events. Hurricane Andrew, by the way, was up to 165 miles per hour over most of our study zone. Not one failure related to not having roof blocking, and none of the homes that we were able to observe at the roof line and in typical practice have any blocking there. The final point I guess I'd like to make is that using a safety factor of 2, which is consistent with other lateral force resisting systems in the code, would, for 125 mile per hour, 125 TLF capacity, which is being asked for, design capacity, and in the 125 mile per hour wind climate there that building was being built, would withstand up to 175 mile per hour wind speed. We're talking an F3 tornado level wind speed. For that wind climate, that's at least. That's not much more, given the nature of the type of wind there, not being a hurricane type of wind, which can have large exceedances in extremes due to the nature of those such events. So you're talking about a 1,000-year return period event or something that this blocking that Bill is asking for as peel with the safety factor 2 would work. And so with that, I think I've covered most of the points I wanted to cover, and would be glad to take any questions you might have.
Questions should be directed through the chair.
Question, Mr. Chair.
Go ahead.
Yes, this is Sterling Strait on the board. I'd ask that you would just take a few seconds and can you clearly and concisely say why 2.0 is the best proper safety factor to use for this sort of situation as opposed to the 3.5 that is currently in use? Thank you.
Sure. For one, it's a traditional number. It's been used quite some time for lateral force resisting system. I will say this, that I condition that safety factor 2 on wind load. For seismic load for wind resistance, typically a 2.8 minimum has been used. Because of the way shear wall assemblies have been tested in the past, and many of the shear wall assemblies in the code have not even been tested. They're based on a 1950s nail theory that is known to be inaccurate. And so you get wide variations of what the real safety factor is. The other factor in this is that shear walls, for example, as a benchmark for safety factors in lateral resistance, they've been tested using what's called the E72, ASTM E72 test. This has a heavy load beam on the top and also has heavy tie-down rods that just wrench the wall system down to basically, it maximizes the capacity you could possibly get out of the system in a way that's not consistent with the boundary conditions that are present in a real building. It's much more rigid, and it actually suppresses failure modes, like cross-grain tension on the bottom plate. That's why we saw that type of failure in the Northridge earthquake for engineered construction, not so much for conventional buildings, because their force transfer mechanism is much more distributed and more of a system with engineered construction, you tend to pull the forces to hard points, and it creates large force concentrations in the system, and you can initiate bottom plate cross-grain bending, and that's not picked up in the design values in the code because of the way the shear walls are tested, as I explained. But when you look at all of that data, even under that condition, their safety factor is 2 at the minimum value. Some of them are less than 2. Just recently, in the STITWIZ document, which is the lateral design standard of the American Wood Council, I'm a member of that committee. APA put forward a proposal for combined uplift and shear resistance using wood structural panels, which is a great concept. I support that. Just as I supported their products by putting the continuous sheet method in the code, because it's just a good way of doing things. Again, with the safety factor 2. Their safety factors that they're using are 1.9 on shear and 2.0 on uplift. I made a point to question, is that documented in a research paper? Indeed it is, and I can send a copy of that to this group if need be, but that's just another example. I've given several examples to staff in prior letters showing clearly that there are examples in the code of a safety factor of 2, and that establishes the minimum benchmark in the code. So I hope I've answered your question. There's a good bit of data, a good bit of evidence to support having a minimum safety factor of 2, and that being consistent with the intent of the building code.
Mr. Crandall, this is Troy Feller with the 3-member panel. I've got a question. Have you seen other jurisdictions adopt similar provisions based on alternative means and methods for, allowable blocking shear?
For allowable racking shear?
Allowable blocking shear.
Blocking shear.
Allowable transfer from diaphragms to shear walls.
This is the first time up to bat for me on this issue with any local jurisdiction. Participating in the ICC ad hoc committee, Walt Bracing committee, this blocking issue was part of the scope of their work. And so we looked at this data as a committee. It included 3 code officials, 3 engineering academic types, including myself and Dan Dolan from the University of Washington, another engineer / architect down in Arizona, and a number of industry reps, including Simpson, Strong Tie, and APA, and American Wood Council. And we looked at this data, and the IRC provisions were based on applying a safety factor of 2 to that.
Okay, and
Now, the IRC has this wind speed cap that's sort of it's not a performance-based cap, it's just an arbitrary cap that kicks you over into another code, but in terms of performance, the basis and intent behind it would be the same in either code.
okay, thank you. And another question. I think you talked to this during the presentation, but I want to be absolutely clear. What I heard is that you feel that the blocking conditions shown in option 5 of the RD13 handout would provide superior strength than those conditions that were tested, that we based the 70 pounds per linear foot with the factor of safety of 3.5 on.
I'm not sure I follow your question. I guess what I'm saying is the 125 pounds per linear foot value can be justified with the testing without any blocking, with a safety factor of 2 without any blocking. And if you look at the data with blocking, it's even better than that. So I think it's a safe number, and I think there's ample precedent in the building code and in lateral force systems that are represented in the building code to use a safety factor 2. That will ensure that your blocking is going to perform just as well as the other systems that are part of the lateral force resisting system.
Okay, thank you.
Mr. Chair, I have another question. This is Sterling Strait again. In the timber code, the safety factors, the non-laterals part of the code, the safety factors applied to different portions of framing vary depending on what the framing is used for. For example, it's lower for bending than it is for specifically for connections. I believe the connections part of the code is where the 3.5 factor of safety came from. My understanding of the reason for this is that you want to kind of direct if there is a failure where it's going to be, you have less ductility in your components than you do in the numbers. So could you speak to that in this case? We're looking at the connection, specific components connecting to
the connection design provisions in the NDS, for example, for wood design, are based on single fastener connections, unless you get into group action stuff, joints, but it's based on single fastener connection behavior. It's not based on system behavior. These are just two members they put together in a test apparatus and pull apart or shear or whatever. When you get into systems of members and connections like we're dealing with here, you need to go to an assembly test. That's why for shear walls, the capacity, if you're going to get ground truth, has to be determined from an assembly test, and the assembly test should be run in a way that's representative of the boundary conditions. I addressed that earlier. So when we ran the assembly test of the roof blocking in both reports, and I wasn't intimately involved in the second report that the Forest Products Lab and NHP Research Center did. They did ask me to review their research plan and look at the final report, but I wasn't, like intimately involved with it like I was in the earlier report at the research center. But when you test the assembly like that and you have the boundary conditions free so that they're acting like the real building as an assembly, then any of the connection failure modes that are going to happen get captured in that as a part of the system, just like it is for shear walls. What causes shear walls to fail? What causes the behavior you get out of them? It's all about connections. But when you get to these assemblies, you have to test them as an assembly. You can't look at just a single fastener and use that as a basis for determining the strength or the safety factor.
So to follow up, the way the code is laid out right now, we design a diaphragm and then we design a shear wall, and then we come back and make sure they're connected well. At least that's my understanding of the code. So in that, the way it's set up now, we're designing two separate systems, and then what we're looking at today is specifically the connection between those systems. Are you saying that connection does not require...
So the way you would do that is design your diaphragm and design your shear walls just like you would normally do, and then you're going to know at that point what the transfer is between the two. And if it's, above 125 PLF, then you're not going to be able to use this option 5 detail. You have to either engineer something else or use a different detail. But if it's under that, then you have sufficient force transfer to meet that. And I qualify that statement only to wind load. Safety factor of 2 is only relevant to wind load design. If you're doing seismic, then you should use 2.8, and I would recommend even going further than that. And in the HUD study we did, we gave an example of how to design for seismic load transfer using that data, and we actually applied an overstrength factor. The current building code does not require you to do that, but in fact, those joints should be designed with an overstrength factor. The wood industry standards don't require it, but it should be. So we're recommending actually to go to a higher standard in the code in terms of engineering practice and using that number for seismic design. But for wind, safety factor 2 is good. For seismic, safety factor 2.8 will give you a good number, but because of the way seismic is designed, using any elastic loads and diaphragms and shear walls with seismic response modifiers that take your loads way down, we would recommend using an overstrength factor to pump that load back up to more of an elastic range load for using this blocking approach.
So just so I'm clear in my mind, you are recommending using the same factor of safety for the connection between the systems as you are for the systems themselves?
Yes.
Okay.
Mr. Crandall, this is Troy Feller again. One concern I have with the details shown in option 5 is there's no boundary nailing that's required to occur along that connection between the diaphragm to the wall. And if there's no plywood joint there, then the only nailing present would be, in the field nailing of the plywood panels, which would typically be 12 inches on center. Do you think that there would be something to be gained by adding some additional nailing from the plywood to the truss top cord above that blocking?
For the typical diaphragm loads you'd see in homes, no, I don't think there would be much benefit in that. And I base that on the fact that when we tested these, we actually drug the force into the heel joint area of the truss through a roof diaphragm system that was installed just the way you described. Now, as you get above, unfortunately, these types of diaphragms that do have strength, because most homes have been built that way, and there's been very, very few roof diaphragm failures or floor diaphragm failures at all that I can think of offhand, and unless you get into some really oddball situations. But all of them have, a certain shear value, but there's no published data on what that is. But when we ran these tests, we know that they're able to drag the 125 PLF in there with that detail, because that was part of the assembly test.
Okay, thank you.
I have one more question. This is Sterling Strait again. This may go back in your memory a little bit, but I want to talk about the specific testing that was done as part of the, I'm looking at the NAHB Research Center report that was put out August 8th, 2011. And specifically, what we're talking about today is the configuration G that was used with partial light blocking and 50% of the wall length. And from my reading of the report, it sounds like the failure mode that stopped that test was cracking or a fastener pull-through of the gypsum ceiling. And the heel trusses themselves did not fail, the diaphragm did not fail. Is this correct? And if so, in your opinion, how much further would the system have been able, how much more load would the system handle if we weren't taking into account failure of the gypsum ceiling?
How much higher before you might have run into like a heel joint type of failure?
I guess how much further could we run to a real structural failure?
I mean, I can't answer that. I mean, there wasn't any, there wasn't any test done to say how much higher that would go, but we do know that it at least goes that high in that particular configuration, and then configuration A and B without any blocking, you can see what was able to be achieved in those particular tests, as I pointed out earlier, with a 9 1/4 inch eccentricity. And the option 5 leaves you with only a 2 inch eccentricity. You're getting 255 PLF. But this explains why there's so few, if any, roof diaphragm failures in conventional homes. The failures you see in conventional homes, even ones that are misassigned to wall bracing, are almost all related to uplift load path failure. If you got the uplift load path, then your bracing system will perform as it should in conventional homes, and things will hold together. That's been the experience from the field. So the ability of transfer force through this system, granted it's a very indeterminate, complex system. That's why we had to do assembly tests to try to benchmark the characteristics of this, and some of them included a ceiling diaphragm, some didn't. And this one, did include a ceiling diaphragm, but it showed that actually was the weak link in this particular test, not the heel joint.
Thank you.
Any other questions?
Mr. Chair, I have one question. Jay, this is Mark Pinello. Could you speak to how material changes, such as different specific gravities or different species could possibly affect the performance of the connections. The testing that was done was all done with a single species, southern yellow pine, which unfortunately is not available in Alaska, and so that's the reason why I ask.
Yeah, what are you guys using, Doug fir typically?
Typically Doug fir.
Yeah, for your roof trusses?
Mm-hmm.
Yeah, looking at the failure modes that occurred, I don't think you're going to have the same type of species effect that you would see in shear walls or in connections. Basically, the blocking, the real, the force transfer, the blocking just acts as a block to prevent the truss from rotating, so it bumps up against it. It's just a compression load. The connection of the block to the top plate now would be somewhat dependent on what's going on with the joint. So, but again, the test we ran didn't even include a block and just had the H2.5 clip, which, by the way, is way underrepresented in its real capacity to resist lateral force in the plane of the wall. But I don't think that would affect anything based on the way the testing was run and the way the blocking was worked. But the block, nailing to the top plate would be the key issue there. I think the top plates that were used in the second report were spruce pine fir, which is in the lower density side of the realm. And that was used with just plywood, 7/16 OSB blocking. The intent there was try to use something as minimal as possible and see how well that would do.
Okay, thank you.
Mm-hmm.
All right, thank you, Mr. Crandall and Ellen. So, staff's rebuttal.
Staff need to be sworn in as well.
Yes.
Okay, who's going to be, just you, Mark?
Yeah, just me.
Are you testifying? Okay, raise your right hand. And do you affirm under penalty of perjury that the testimony you're about to give in the matter before us is the truth?
I do.
All right, go ahead.
So with regards to staff position on this, Jay, thank you for your testimony. Actually, there was a lot of information that you provided that was not available. That actually does materially affect my personal position on this. So I do thank you for that. As a general rule on staff position, though, the biggest concern that we really had was with regards to the amount and type of testing that was done. I do agree with Mr. Crandall that the kind of the envelope approach that they did can provide a better range per se, but doesn't necessarily quantify what happens in a particular configuration. There might be a particular failure mode that occurs in one particular test, but you reconfigure or you reassemble that configuration, new materials, you might come up with a different failure mode. And so that sort of thing wasn't really captured in the types of tests that were done. And part of the reason, at least in my understanding, why multiple tests are done is to ensure that the types of failures that can occur with a particular configuration are captured within the scope of testing. And then with that, then increase the scope of testing beyond that to capture the rest of the failure modes, to give yourself an envelope capacity, and then figure out what's important, what's not important, and then come up with a good design value that you can use, regardless of what factor of safety that you use. As to the points that were made in the staff memorandum, AC 13 was used as a basis. It wasn't to come up with a factor of safety. It wasn't the be-all, end-all, thou shalt use a factor of safety of 3. But in terms of acceptance criteria for testing, staff felt that what we're dealing with is a connection. We're dealing with a concentration of forces into a smaller region coming from one diaphragm, a horizontal diaphragm, into another. And so typically, as Mr. Straight had pointed out, connections tend to have a higher factor of safety. But with Mr. Crandall's testimony that in a lateral system sense, it does act as a single unit, so is it possible to use the same factor of safety? You can make arguments one way or the other, but since we were talking about a connection and the approach wasn't necessarily dealing with wind, we are also having to account for seismic since we are in a fairly high seismic area. Choosing one factor of safety for wind and another for seismic is doable, but kind of makes the policy that much harder to deal with, because now it really forces the designers to understand the differences between wind loadings and seismic loadings and how the building responds with regards to that, and what loads can you actually dump into that particular connection. So that was kind of the reason why AC 13 was used. It was not so much because that was the only thing that was there, but it was an approach that made sense. We're dealing with a connection. Connections tend to have a higher variability and should less ductility, and so oftentimes require a higher factor of safety. You see that with other materials as well. You start looking at steel design, for instance. Shear and bending and member, you tend to have either a moderate or a low factor of safety or a high resistance factor, depending on which direction you go. But as soon as you get to connections, you start looking at higher factors of safety. Concrete's the same way. Masonry is the same way. And with wood, we have the same thing. Member design, connection design. You want to take a look at it from that particular standpoint. So factor safety should be a little bit higher. As far as the second point, of which I'm missing that particular page, the point was to show that wood has a high variability. Given that it's a natural product, the actual capacities from member to member can vary radically. And the same thing goes with assemblies, is that you can have a fairly broad amount of capacities even with the same assembly, just because of the material changes in material. Third point, with regards to the representation, I think Mr. Crandall addressed that particular aspect in his response to my comment on materials. Because of the fact that we have different materials, the concern was whether or not the specific gravities primarily would have any effect or any material effect on the capacities. And in his particular testimony, mentions that probably would not be as influential on the capacity, and that the blocking to top plate would be more apropos to address. And so on that particular point, I will say that I do agree. But overall, I think there is still a question as to whether or not the factor of safety should be applied from a connection standpoint versus a system standpoint. And as I mentioned before, the big concern is that the lack of testing in a particular configuration to determine what the limiting failure modes are is what's lacking. If that information was available, this conversation would not be happening. Speaking to the alternate means, specifically, the appellant doesn't have any specific reason why any of the other options are not viable, or why even option 5 currently as it stands is not viable. Options 3 and 4, the background behind the handout was primarily to address the conflicting provisions of ventilation in the roof cavity and the connection of the roof diaphragm to the wall. Options 3, 4, and 5 provide the same level of ventilation. Option 3 has no capacity limit. Option 4 has a higher capacity limit than what option 5 does. But there's nothing in what was provided that says that the other 4 options are not viable. There's also nothing that was provided that says that he could reconfigure the system to make option 5 viable as it stands. So in that particular sense, there is, in speaking to this, there is no specific individual reason why the alternate means, or that interpretation of the code as was provided by the building official was incorrect. Regardless of that particular stance, the building board is granted the authority to provide for modification of the building code. Following that, the 5 standards as listed in the in Title 23 are followed. Item 1 is that the modification is in keeping with the intent and the purpose of the building code. Staff feels that this standard hasn't been met, mostly because of the fact that staff feels that there isn't enough testing to really determine if the capacities that were shown in the testing are the prevalent failure modes that would limit it. Jay mentioned several other testing protocols, or not testing protocols, but test results that may influence that fact. I have not seen those, and if that information is available, we definitely can take that into consideration. But until such time, staff feels that there just isn't enough testing available to make that particular call. Item 2 is that the modification does not lessen health, life, or fire safety for the people of Anchorage or the structural requirements in code. Staff also feels that this standard has not been met, not from a life safety standpoint, because the ventilation is being provided by this particular method, but as with item 1, it feels that the structural revisions have not been fully met. Item 3 is that the strict application of the building code would create an exceptional or undue hardship. In this particular case, the standard has not been met because there are other options that could have been employed that would have satisfied the requirements of the building code as is currently interpreted. As noted, there is no evidence that the roof ventilation issues that have been prevalent within Anchorage are solely because of the application of the details in RD 13. Item 4 is that a modification shall not extend to waiver of actions that are necessary to correct violations of the building code. The standard is not applicable as this is not extending a violation. It is specifically an interpretation of what is currently available. Item 5 is that exceptional or undue hardship will not support a modification unless a modification is determined to be equally safe. Staff also feels that this particular standard has not been met, as that there is no evidence that the details cannot be constructed as shown without undue hardship. Part of the concern is whether or not framers go up and do blocking in the roof, but you've got framers that do block roof diaphragms all the time. And so the construction is definitely doable. Instead of doing the entire roof, we're only looking at blocking at the eave line. So that particular aspect, there really is no undue hardship there. There's nothing that is physically stopping the construction of those details as shown. In summary, it's that nothing has been provided that's showing that the details as currently shown are deficient in what they are intended to do, both providing ventilation of the truss space and of providing an adequate connection between the roof diaphragm and the supporting walls below. The argument also, staff feels, is that it doesn't show that the approach is not valid. Staff also feels that it is conservative, but without the testing, is that some level of conservatism is warranted.
Okay, thank you, Mark. Are you finished?
Yes.
Okay, and any questions? Staff's testimony.
I have a question, Mr. Chair.
Go ahead.
Mr. Pennell, you previously, when we first started this, I believe, correct me if I'm wrong, but we used the factor of safety of 3.5, is that correct?
That is correct.
Could you briefly go over how you came up with that? And do you still feel that that is a proper factor of safety used for this case? In light of the gentleman's testimony.
So, speaking to the first part with regards to coming up with a factor of safety, as mentioned in testimony, is that AC13 was kind of used as a basis to come up with a number, not necessarily saying we shall test to AC13, but AC13 provides a factor of safety of 3 for connections. The rest of the modifications to the factor of safety was primarily based on the Forest Products laboratory testing. That is the testing that was done in 2011. Of the configurations that were shown, 4 were selected that were representative of the heel height and of the type of configurations that we would see either with the partial height blocking and or hurricane clips. The capacities of those shown range from 200 to 240 pounds per linear foot of peak capacity. The requirements for testing in other protocol usually requires several tests. AC13, for instance, requires a minimum of 3 for where you're using a lower bound value, or 6 where you can use an average. But because of the configurations that were provided here, even though we don't have the 6 tests, using a lower bound approach didn't seem reasonable. And there's more capacity there than we would realize just because of the differences in the heel height that we typically use plus the additional blocking. There was a question with regards to the specific gravity as to whether or not that would affect the capacity. And so the difference between Southern Yellow Pine and Doug Fir was included with that, and that turned out to be a factor of about 0.87 when you look at the ratio between specific gravity for Doug Fir Larch divided by Southern Pine. Before I go any further, because of the testimony with regards to the materials, I think this particular factor can definitely be removed. Next item was the fact that none of the tests used continuous eave blocking, i.e. every truss bay was not being blocked. Configurations F and G, which had either 25% or 50% respectively, was used, but there was a question as to whether or not there was a linear relationship between increasing the blocking, the number of block bays, and increasing capacity. So it wasn't quite clear as to how to apply that particular aspect. From a conservative standpoint, it's safe to ignore that because it's likely that there would be an increase, but whether or not it's linear, it was not easy to tell from the data that was available. Finally, was with regards to the overall determination of the capacity, was that because of the configurations, because of the number of tests, it was either use a lower bound value, an average, or an upper bound value. Because of all the mitigating factors, we used an upper bound value to allow for higher capacity versus what can be or has typically been done with other types of tested assemblies. Applying all of those factors, we have a factor of safety of 3, and applying it with primarily the specific gravity is how we came up with a factor of safety about 3.45, rounded up to 3.5. But as mentioned before, that the specific gravity could be reduced or eliminated from that calculation, at which point then a factor of safety of 3 would be applied. Running a quick calculation on what we have here. So with that, if you look at it from an upper bound standpoint, or sorry, from an average standpoint, it would be about 75 pounds per lineal foot, but if you use an upper bound with a factor of safety of 3, it would be about 80 pounds per lineal foot. Following the development of this, staff had gone through and looked at whether or not 70 pounds per lineal foot would be capable of addressing or figure out what percentage of residential construction in Anchorage this would actually address. And there was a consensus that the vast majority of construction could be addressed with a 70 pound per lineal foot capacity. We also looked at the demands prescriptively on a partial height blocking connection, and the calculations showed roughly 70 to 80 pounds per lineal foot if you took a prescriptive house and engineered it.
Thank you.
Any other questions for staff? Does the appellant have a rebuttal to staff's presentation?
Oh, yes, we do, Mr. Chair. Before I defer to Jay for any thoughts he may have in response to the engineering points made, I wanted to make a point about the standard applicable under the code. As I noted in my introduction, under the municipal code, the building official can grant either a modification of the building code or a request for alternative materials, design, and methods of construction equipment. The standard is different under the code. The standard that Mr. Pannella is applying is the standard for a modification of strict application of the building code, which is not what we've requested. We've requested an alternative means and methods of alternative materials, design, or methods of construction. And so the standard for that, I'd like to read into the record, which is, it shall be approved when the building official finds that the proposed design is satisfactory and complies with the intent of the provisions of the code, and the material, method, or work offered is for the purpose intended, at least the equivalent prescribed in the code, in quality, strength, effectiveness, fire resistance, durability, and safety. And I think that removes this requirement for there to be a specific issue with the alternative. So that's the core of that point there, is that the modification request requires that there's a specific issue that the other, specific reason that the other standard cannot be applied, or the specific reason that the other alternative cannot be applied. And the alternative materials design and methods of construction standard does not require the other options being possible. It just requires that this be in keeping with the spirit of the code and meet that requirement. So I just wanted to make that point. And then, Jay, I'll defer to you to respond to the engineering points.
Okay. Yeah, Mark, thanks for sharing that. I appreciate your comments about my earlier testimony. One of the things I guess I'd like to point out is that different failure modes not being captured. We did test this as a full assembly. And if you look at testing precedents in the code that I mentioned earlier, shear walls are tested and are used with significant failure mode suppressed based on the test methods that were defined. We did not do that and allow the system to perform as a system. And I think the numbers as a result are more reliable on that basis than many of the numbers that are currently in the code that you would get when you're testing or using design values for lateral force systems. One of the other points Mark mentioned was higher safety factors for connections. Shear walls and diaphragms are all about connections. And we're not testing a single fastener, and you're not going to get an accurate design, like I think Mark had mentioned doing a design solution. You're not going to get an accurate design using single fastener design approach in the code. You've got to test this as a system to get good numbers. And that's why we did that. That's why shear walls are tested as systems, even though they are all about connections. And again, the minimum safety factor that's used there is a safety factor of 2. But the caveat for seismic should be done with a safety factor of 2.5, and that 2.8, that raises the question Mark had about designers being able to handle 2 different design values, one for wind at a safety factor of 2 and another for seismic at 2.8, and if they don't know how to do that already, then they're in deep trouble, because that's the way the whole wood frame design system is set up for shear walls and diaphragms. So I would think that when they do their seismic check and they use the safety factors for shear walls and diaphragms, it makes sense to use the same approach for designing the force transfer. So I don't think that will add any complexity to the designer, and in fact it would probably make more sense to them. As far as mesh ductility, these systems demonstrated adequate ductility, similar to that which you get out of a shear wall. In fact, one of the things that's not accounted for in engineering is the more you make things rigid from a seismic design standpoint, the more load you created. And our design methods do not even begin to account for that. They're just not that refined for seismic, but that's exactly what happens to a structure. The more you try to strengthen it, the more load you create for yourself to resist, and the more rigid you make it. And that's just an unfortunate consequence for seismic design, but that's why they have larger safety factors for that, and I'm advocating that that application should be done for all these connection details that are in the current handout that the department's using. Let's see. Let's see what else. I think that staff Mark had mentioned that they feel this doesn't meet the intent of the code, but what I would suggest is that the handout they have and the design value that is signed does not meet the intent of the code. That is why we're here. There's one of the examples they were provided earlier of a minimum safety factor of 2 being used for lateral force systems in the code. So the issue here is meeting the intent of code being equivalent. That's the primary principle in the alternative means and methods clause of the code is to be at least equivalent, and this design and the suggested safety factor of 2 will achieve that. The harshness that's created when you don't do that is, in this case, then you cause more costly construction when it's not necessary. The same things happen, by the way, in ICCES process, in their use of safety factors. Certain advocates might push for a higher safety factor. Well, why? Because the new guy that's coming in with an innovative solution on their alternative means and method is going to be a competitor. And so the safety factor is a means of controlling competition. But from the design realm, as a designer, a building designer, we just want to have the right number and a fair level playing field to use to get a good answer that's consistent with what else is done in the code. And that is why this is being brought forward, that this particular detail should be assigned a safety factor that's equivalent to what's in the code. And it has not been done. So I think I've addressed most of the points I had jotted down. Again, it's kind of hard to keep up with things over the phone, and I apologize for that, but I'll conclude with that.
All right, thank you, Mr. Crandall.
Mr. Chair, if I may make a comment. Jay, could you would be available to tell the designers that parallel wind and seismic calcs are kind of necessary? As an aside, that's one of the issues that we've always been having with regards to structural design from a residential standpoint, is that has been a concern that we've been trying to address for years, and hence part of the reason why simplifying the details as we've had it has been of a benefit, because of the fact that we've got designs that can be ultra conservative in one standpoint and not conservative at all in other standpoints. But we'd like to, since I have you on the phone, to make that statement.
Okay, I'm sorry, I didn't hear the very beginning of what you were saying. I apologize.
Yeah. You made the statement with regards to my comment on different factors of safety, wind versus seismic, in that seismic or designed for single-family dwellings oftentimes miss that fact that they do need to provide parallel calculations. Because of the
They're not providing parallel calculations for both wind and seismic?
Correct. Hence the reason why we try and simplify have simplified in the past the details and a lot of the design requirements.
Okay.
Yeah.
That seems like to me it's an education issue. I mean, that's a pretty serious code compliance issue, not to check both load actions. I imagine at 125 mile per hour wind, that's going to control a lot of things. At least that's been my experience, even in the high seismic areas as far as design goes. But nonetheless, the systems should be checked for both load actions.
Right.
That's a design standard of care issue. I would kind of feel that penalizing those that do know what they're doing by assigning a big safety factor to cover those that don't know what they're doing is not probably the best way to deal with it.
Thank you, Jay.
And you're welcome.
Mr. Chair, I have a couple questions, if I may.
All right, go ahead.
Before we go to questions with Mr. Taylor,
No, go ahead.
sorry, you were, okay.
Yeah, I'll just
I'll
wrap
give
up.
the chance to, is one more thing you'd like to say
I just
before
have one thing.
we give up our chance to give rebuttal testimony?
Okay, thank you. Through the chair, Mr. Crandall, it did mention that this is the only testing that we've seen. Are you aware of any other testing that has been completed on partial height blocking in a combined configuration such as this?
I'm not. No, I'm not aware of any other at this point.
Darn. We've been looking for it, we just can't find it.
Yeah, I know that the structural building components lab at one time, since, this is related to a trust issue, was looking into that, doing that. I don't think they ever did run through the test. I'm in communication with them pretty frequently, but I think they're kind of, looking at these tests as sort of the benchmark at this point in time.
Thank you. And another question for Mr. Taylor, since you're here. It's been brought up by the staff that there's no real hardship for causing this, but obviously you've been through much expensive time for bringing us all here today, so you must have a very good reason for wanting to change this. I was wondering if you might elaborate, take a few minutes to tell us why you would like it changed and how it would help you as you're representing the Home Builders Association as well.
Yeah, this started, maybe 2 years ago, I had a discussion with Sharon about just creating the opportunity to provide better ventilation for houses, because I think, in my opinion, that's where the failure mode is. You can engineer a house to death, but if you don't ventilate it properly and you create, mold and rot, the engineering doesn't do any good. So in my mind, and it's very simple, what I want to do and try to accomplish is just provide a means for builders to have the incentive to ventilate a house properly. And I don't want to put any impediments in their way, like additional blocking. And Mark, I understand that, the framers are up there, but they have better things to do than overblock. So I want to make sure that the industry has this opportunity, if you want to call it, to ventilate properly. And I feel strongly that this blocking is unnecessary. And I think, after I've looked at it, I'm certainly not an engineer, but I think I'm looking for reasonableness. I think 3.5 is overkill. I think 2 is more consistent with what the code says. And since we don't have any failures at all, there's none that are documented. So with that in mind, it's simple to me. Make it easy, make it simple, and then let the builders ventilate those houses properly, because 9 out of 10 builders these days use full height blocking with holes drilled in it. It's a terrible system, terrible. It creates a lot of restriction in the ventilation. So let's go back, let's give the builders a reason to go back and use partial height blocking, which is what we did for years and years. And this safety factor of 2 kind of opens the door a little wider for us to use that.
Thank you.
Okay. So I think we'll move to the phase now where the panel discusses the evidence.
Does that cover what you want to say, or do you still have more that you want to?
No, unless you have some rebuttal.
I have nothing else to say.
I was assuming that covered your conclusion as well as answering Mr. Straight's questions.
It did.
Well, thank you for that. So we'll move to the phase now where the panel discusses the evidence. And the way I'm looking at moving forward is that this appeal is granted or not by a vote of the panel. And so that's, I think, the end goal.
Mr. Chairman, if I could make one important point, the end goal is to rule on the appeal and then also provide an option in AG 15 that allows partial light blocking without the interior or exterior wall blocking. So it's a combination of two goals.
Without the interior or exterior wall blocks?
The option, all of this, yeah.
So the goal is to go to specific, appeal as it pertains to this specific property, and also a general recommendation regarding that option 5 standard for RD 13.
And that's stated within the appeal.
Yes.
So by granting the appeal, we would accomplish that. Because
Okay.
the appeal doesn't just address the project, it also addresses option 5.
Yeah.
A change to
Just
option
want to
5.
remind everyone.
Okay.
This is Jay on the line. If I may, I just have a quick question too to make sure my testimony is consistent with what I understand is in the current option 5. I heard some mention earlier about having every other blocking or something like that. But my testimony and support for the safety factor 2 and the design value 125 was based on that blocking being continuous every truss day. And I presume that's what's intended in this option 5. I just wanted to make sure.
I think everyone's nodding, but no one's saying yes.
Okay,
Well, I guess that's a good point, because option 5 doesn't specifically say every bay, it gets applied, but it doesn't specifically say that.
If that's a point of confusion, could be a point of confusion because the IRC against what my vote was on the ad hoc committee allowed it to be placed only at the Shearable Hall lines, and you get much better force distribution when you have it along the whole eave, and you got actually a lot more blocking than perhaps you need when you do that, but it just is a more continuous system, and that's what's intended in option 5, and perhaps that should be clarified in option 5, but that's the better way to go.
Yeah, I think that's an industry standard, that it's blocking every bay, Jay.
I think that's the intent of option 5. Mr. Straight just pointed out to me that options 1 and 2 in the handout specifically say that, but option 5 doesn't, so I think that's a clarification that probably should be made. So that's just I guess a note to staff if option 5 is amended to make that more clear.
So noted.
Perhaps option 3 and 4 as well, same.
Correct.
Mr. Chairman, just thinking off the cuff here, if the board does approve this appeal, then does it make sense to eliminate the other options in the handout and just allow this? Because if you have higher loads, you're going to be diaphragm blocking anyway. So I think the diaphragm blocking requirement with higher loads is already there. So why not eliminate the interior blocking and exterior blocking and just cross that off, eliminate it, and make it simple for everyone that's trying to understand it.
Mr. Chairman?
Yes.
Two comments as you begin your discussions. Please make special note of item K, that burden of proof rests with the appellant and must convince the board by preponderance of the evidence that the appeal should be granted. So keep that in mind. And second, I believe it would be improper to go outside the scope of the appeal and begin making other modifications to handouts. I think your proper business is to look at the appeal before you rule on it as it is.
I agree, and that's why I started off by saying that the panel's goal is to grant the appeal or not by a vote. And so let's try and keep just to the appeal, and the appeal addresses option 5.
Mr. Chairman, just a quick thought, if it's within the scope of the board to make a recommendation about the other ones, I think I'd like to see that. But if it's not, that's fine.
Well, I don't think it is based on this appeal, but I think it's a moot point because options 3 and 4 wouldn't be used, so whether they're there or not. I mean, they wouldn't be used if the appeal was granted, so.
Yeah, that's a good point.
Okay, so I think from this point forward, it's just going to be the 3-minute panel discussion. If we have questions, we can ask questions of those present. I'll start off by kind of summarizing it the way I'm seeing everything after listening to the evidence. We've had extensive discussions on this issue, and where we arrived is that based on tested assemblies and using a factor of safety of 3.5, that 70 pounds a lineal foot was acceptable for option 5. The factor of safety of 3.5, in my mind, was essentially arrived at by being the lowest factor of safety that was acceptable to all parties involved in the discussions, and therefore was conservative. Based on the evidence that's been presented, I think a factor of safety of 2.0 would be appropriate. And especially considering that the tested blocking assemblies are probably substantially weaker than the blocking assembly shown in option 5. So from that standpoint, my opinion is that the appeal should be granted. Other discussion?
I would concur. I hesitate mostly for the standpoint that the connection between systems is a point of possible inelastic failure. Non-ductile failure would be what I'm looking for. But I agree that this works as a system. I think we all agree that the testing that's been done gives a very conservative answer on top of our conservative factor of safety that's been previously used. And that it only had blocking every other bay, and the failure mode was the gypsum ceiling failure. There was not an actual structural failure in that test. Based on those, I would lean towards granting this appeal.
After Bill was kind of clarified himself a little bit there about really why you were looking into the appeal, where you just wanted more ventilation to get up into the attic cavity. And that is kind of a sensitive spot with me, because that has been a problem. And I know in the past, we went back and on some of the homes that we've done in the past where we only had partial height blocking, where we get full free air movement up through this thing and just put a screen up there or a soffit system with a bird screen in it or something. It just ventilated that attic space so much better. And I think the way they have it now with the birds blocking in it certainly does limit the ventilation, even though probably everything calculates out okay, that there is still a problem with that. So with the safety standpoint, that it sounds like everything is fine, I would have to your appeal is what I vote for too.
One more comment before we vote, and we're still open for additional discussion, but one point that was brought up is seismic versus wind. And I think the way to handle that, if option 5 is revised, would just be to say that it would be the diaphragm shear based on the code prescribed load combinations. And for seismic, the load combination has a load factor of 1.4, and for wind, it has a factor of 1.0, so that would kind of take care of itself. And that would be consistent with the factor of safety of 2 versus kind of 2.8 for seismic and 2.0 for wind is kind of a couple figures that were thrown out there, which I think are reasonable. So I think that could be handled in the rewrite of option 5 in that way. Any more panel discussion before we vote?
So you're saying the load combinations will take care of the 2.0 versus 2.8?
Yeah, if option 5 is rewritten to say that the diaphragm shear based on code prescribed load combinations would be 125 pounds lineal foot, because a load combination for seismic would include a factor of 1.4, and for wind it would be 1.0. Which would equate to a factor of safety of 2.8 for seismic and 2.0 for wind. Okay, we're ready to vote. All in favor of granting the appeal? Aye.
Aye.
So the appeal is unanimously granted. And meeting's concluded.
We should let the staff know about their options for appeal if they choose to do so.
I think they know that. All right, thank you, everyone.
Thank you, Jay.
You're welcome.
Have fun in Dallas.
So,
I just wish it was a